positive integer and be a fixed positive integer. Suppose I'm taking two integers A and B. Two integers A and B, congruent modulo n. అంటే n అనేది ఎనీ ఫిక్స్డ్ నెంబర్ తీసుకుంటున్నాను, అది పాజిటివ్ ఇంటీజర్ అయి ఉండాలి. AB ఆర్ ఎనీ ఇంటీజర్స్, A congruent to B modulo n, అంటే the integers A and B congruent modulo n. Now the condition is if n divides A minus B. N divides A minus B means A minus B is divided by n. A minus B is divided by n, or A minus B is divisible by n. Then we say that A is congruent to modulo B అని చెప్తాము. దీన్ని ఎలా రాయొచ్చు అంటే that means A congruent to B, it can be written as A congruent to B modulo n if this exists when n divides A minus B. This exists when n divides A minus B. A congruent to B modulo n if n divides A minus B. You observe here both A and B are integers. N is a fixed positive integers. Right? Now, if my note is that if n divides A minus B, then there exists, by divisibility condition, n divides A minus B, then there exists K is belongs to Z. That means what? A minus B is divided by n. Suppose A minus B is divided n, so this is some K times of remainder should be 0. Therefore, it can be written as A minus B is equal to, if n divides A minus B, there exists K belongs to Z. Okay, such that even write you A minus B is equal to, by divisibility property, A minus B is equal to n times of K. A minus B is equal to n times of K. This is equal to A is equal to B plus nk. K belongs to Z. A is equal to B plus nk, where K belongs to Z. That means what happens here exactly? If A congruent to B modulo n, A congruent to B modulo n, if A is equal to B plus nk. A is equal to, if A congruent to B modulo n, if means here n divides A minus B. N divides A minus B means A minus B is equal to nk. Therefore, we can write A is equal to B plus nk. If A is equal to B plus nk, then A congruent to B modulo n. This is the relation. అంటే ఇక్కడ one more thing you observe here, whenever this condition is satisfied, we can write this as A is equal to nk plus B. A is equal to nk plus B. It's look like A is equal to, you observe that A is equal to BQ plus R. A is equal to BQ plus R look like. Then whenever A is equal to BQ plus R, by division algorithm theorem, GCD of A comma B is same as GCD of B comma R. GCD of A comma B is same as GCD of B comma R. So you observe this point is, notice that. Later I will say whenever A is equal to nk plus R, this means GCD of A comma n is equal to GCD of n comma B. Already we discussed this condition. Manaku already A is equal to BQ plus R by Euclidean division algorithm. GCD of A comma B is same as GCD of B comma R. By this condition we can write. The meaning of this is equal to, what? If A congruent to B modulo n, A congruent to B modulo n, if GCD of A comma, A congruent to B modulo n, then GCD of A comma n is congruent to, is equal to, exactly equal to GCD of n comma B. ఇలా రాయొచ్చు. Right. This is one of the important property. Major గా మీరు ఇక్కడ గుర్తుపెట్టుకోవాల్సింది ఏంటంటే A congruent to B modulo n means if n divides A minus B, A is congruent to B modulo n. Modulo n, this number n must be a positive, fixed positive integer. Right? Now, I'm giving some properties of this one. Right. Now, what is the first property? Example, okay, simple example is done. Now, first my giving example. Now you say, what is 11 is congruent to 2 modulo is modulo 3. Is it correct or not? 11 congruent to 2 modulo 3. Is it correct or not? My question is this one. Eppudi ఇది possible అవుతుంది? If 3 divides 11 minus 2, 3 divides 11 minus 2, then only this is correct. So 3 divides 11 minus 2, a minus b. N is equal to 3, a is equal to 11, b is equal to 2. 3 divides 11 minus 2 means what? Is it correct or not? This means what? 3 divides 9. Yeah, 9 is divided by 3. It is correct. It is true. Whenever this is true, whenever 3 divides 9 is true, then what you say? 11 congruent to 2 modulo 3 is correct. This is the correct congruence relation. This correct congruence relation. Number two, 13 congruent to 4 modulo 10. Is it correct or not? Now you check. 13 congruent to 4 modulo 10 కావాలంటే ఎప్పుడు కావాలి? If 10 divides 13 minus 4, this relation is true. Now you see, modulo is 4, 10 divides 13 minus 4. Is it correct? 10 divides 13 minus 4 means 10 divides 9. Is it correct? This means 10 divides 9. Is it divides or does not divide? 9 is divided by 10? No. So that 10 does not divide 9. 10 does not divide 9. So we say that 13 is not congruent to 4 modulo 10. 13 does not congruent to 4 modulo 10. అంటే ఈ congruence relation exist కావాలి అంటే if n divides a minus b, if n divides a minus b, so that a is congruent to b modulo n. You observe here, if you observe here, 11 is congruent to 2 modulo 3. Is it 2 congruent to 11 modulo 3? So a congruent to b and b is congruent to a. This is one of the relation. You see, 2 congruent to 11 modulo 3 means 2 minus 11. 2 minus 11, that means what? 3 divides 2 minus 11. 3 divides 2 minus 11 means what? 3 divides minus 9. Minus 9 is divided by 3. Yeah, it is correct. So we say that a congruent to b is same as b congruent to a. This property is known as symmetric property. Right? One more idea is, the most important point is, ఇది ఇంతకుముందు ఎగ్జామ్ లో కూడా అడిగాడంటే JL లో, the congruence relation is an equivalence relation. The congruence relation is an equivalence relation. The congruence relation is dash as a relation అని అడిగాడు. Congruence relation is an equivalence relation. Equivalence relation means it's satisfying 3 properties. Equivalence relation means it's satisfying 3 properties: reflexive property, number 2 symmetric property, another one is transitive property. Later I can prove this one. So a congruence relation means reflexive property means what? A is congruent to a is relation to a modulo n. A congruent to a modulo n, it is called as a reflexive property. Symmetric property means a congruent to b modulo n, then b is also congruent to a modulo n. This is called as a symmetric property. Then transitive property means you take 3 elements a, b, c. If a congruent to b modulo n and b congruent to c modulo n, then automatically by transitive property a is also congruent to c, a is congruent to c modulo n. So these 3 properties is known as the equivalence relation. A congruence relation is said to be an equivalence relation whenever these 3 conditions are satisfying. That relation is called as a equivalence relation. Right? I'm giving some properties. Okay, before that, yeah, I'm discussing one CSIR question. Before the going to properties, I'm giving one CSIR. Previous CSIR question, it is part B. Part B lo more than one options kuda untayandi. In part B, more than one options also correct. Option section kuda untundi. Right. My question is very simple question. A is congruent to 1 modulo 1024 ఇచ్చాడు. A congruent to 1 modulo 1024, then అని చెప్పేసి 4 ఆప్షన్స్ ఇచ్చాడండి. ఫస్ట్ ఆప్షన్ GCD of A, 1024 is equal to 1. B, GCD of A, 1024 is the first not equal to 1. This is the second one is equal to 1. Third option is GCD of A, 1024 is equal to 2. D, GCD of A, 1024 is greater than or equal to 2. These are the 4 options. It is a complete, this problem is based on congruence relation. A is congruent to 1 modulo 1024. Then, yeah, look, very simple question. Already we know that in general, when A is congruent to B modulo n exists, in general, A congruent to B modulo n exists if n divides A minus B. A congruent to B modulo n exists if n divides A minus B. What is the meaning of n divides A minus B? N divides A minus B means there exists K belongs to Z such that A minus B is equal to some n into K. Right? Therefore, we can write this as A is equal to B plus NK. A is equal to B plus NK. Just when I discuss this one. This is also equal to A is equal to NK times of B. Now you observe here, it in the form of A is equal to BQ plus R. It's look like A is equal to BQ plus R. GCD of A, N is same as GCD of N, B. Right? I mean, by Euclidean algorithm, n right, GCD of A, N is same as GCD of N, B. Sir, ma దీని దానికి ఏముంది అనొచ్చు. Now what is the given equation here? What is given that A is congruent to 1 modulo 1024 ఇచ్చాడండి. Yeah, అంటే మీనింగ్ ఏంటిది? This exists if what happens, this is 1024 divides A minus 1. 1024 divides A minus 1 అంటే ఏం రాయొచ్చు మనం? A minus 1 is equal to 1024 times of K. A minus 1 is equal to 1024 times of K. Or directly కూడా వాడుకోవచ్చు. This is equal to A is equal to 1024 K plus 1. So GCD of this is equal to GCD of this one. So GCD of A, 1024 is same as GCD of 1024, 1. Yeah. GCD of A, 1024, GCD of 1000. Do you know what is the GCD of 1024, 1? It's simply GCD of 1024, 1 ఏం ఎక్స్ప్రెస్ చేయొచ్చు? It is 1. Because of 1024 ఏమని రాయొచ్చండి? 1024 is equal to 1 into 1024. 1 ఏమని రాయొచ్చు? 1 is equal to 1 into 1. So common divisor is 1 only. Therefore, this is equal to 1. So that GCD of this is also equal to A, 1024 is equal to 1. Simple idea, simple technique. By using this simple technique, we can see. So GCD of A, 1024 is 1. B option is correct one. So you remember that మీరు గుర్తుపెట్టుకోవాల్సిన విషయం ఏంటంటే ఇది మెయిన్ కాన్సెప్ట్. A congruent to B modulo n, it can be written as A is equal to NK plus B. Therefore GCD of A, n is same as GCD of A, n is same as GCD of B, n. ఇది గుర్తుపెట్టుకుంటే సరిపోతుంది. ఫర్ ఎగ్జాంపుల్ మీకు ఇలా ఇచ్చాడు అనుకోండి. ఫర్ ఎగ్జాంపుల్ ఇలా ఇచ్చిండు. సో if 11 divides 11 congruents to modulo 3 అంటే ఏం రాసుకోవచ్చుదండి? 11 divides 11 congruents to 2 modulo 3. This implies what is the GCD of, you see, observe, GCD of a comma n. GCD of a comma n అంటే 11 comma 3 is same as GCD of what you write? GCD of a comma n is same as GCD of, yeah sir, this is yeah, tell me that, anybody, e chart box, right? So here I am giving the formula. GCD of a comma n is same as, then can ask 11 comma 3, GCD of a comma n is same as GCD of, yeah, anybody, you chart box, ఇక్కడ మీకు ఇచ్చానండి. a congruents to b modulo n is equal to GCD of a comma n is same as GCD of n comma b. GCD of n comma b అంటే ఇక్కడ 3 comma. So already these 3 and 2 are the relative prime numbers. This GCD equal to 1. Therefore you have to say that GCD of 11 comma 3 is also 1. అంటే జస్ట్ ఐడియా కోసం ఇచ్చాను ఎగ్జాంపుల్, సింపుల్ ఎగ్జాంపుల్. సో సేమ్ ఐడియా ఈ ప్రాబ్లం లో కూడా ఆ ఐడియానే వాడాడు ఇక్కడ. ఇచ్చి 4 మార్క్స్ క్వశ్చన్, యాక్చువల్లీ ఇన్ సిఎస్ఆర్ నెట్ లో 4 మార్క్స్ క్వశ్చన్, రైట్? Now I'm giving some properties of this one. Properties. These are the most important properties in congruence relation. వీటి మీద క్వశ్చన్స్ అడుగుతా ఉంటాయి, డైరెక్ట్ క్వశ్చన్స్ వస్తూ ఉంటాయి, రైట్? Let my number n is greater than 1 and I'm taking a, b, c, d. These are the 4 members or integers. A, b, c, d are the integers. N is greater than 1. Now my first property, ఇంతకుముందు చెప్పాను, congruence relation is an equivalence relation. Congruence relation is an equivalence relation. So that the first property is reflexive. A is congruence to A modulo n. Second property, A congruence to B, symmetric property. A congruence to B modulo n. A congruence to B modulo n if ఇది కనుక ఎగ్జిస్ట్ అయితే, then B is also congruent to A modulo n. This property is holds. This property is called symmetric property. It is a reflexive, right? Now the transitive property, if A congruent to B modulo n and B congruent to C modulo n, then automatically A is congruent to C modulo n. First last to relation ఉంటుంది, right? Then fourth property, now additionally this is, if A congruent to B modulo n, I'm taking 2. If A congruent to B modulo n and ఇంకోటి ఏం తీసుకుంటుందంటే A, B, C, D. C congruent to D modulo n. These are the 2 results. A is congruent to B modulo n, C is congruent to D modulo n. Then we have, now you can add left hand side. A plus C is congruent to B plus D. Modulo same, modulo n. A plus C, ఈ రెండింటిని యాడ్ చేస్తే left hand side, A plus C congruent to B plus C modulo B plus D modulo n. Next multiply చేసామనుకోండి, A into C, left hand side, A into C, AC congruent to BD modulo n. AC congruent to BD modulo n. Difference kuda, and also difference A minus C congruent to B minus D modulo n. A minus C congruent to B minus D modulo. These are the most important properties for solving of the problems. Number 3 లో వేరే ఏముండదండి, ఇవే ఉంటాయండి. So if 2 congruence relations are there, then left hand side sum, right hand sum, modulo చేంజ్ కదండి, modulo సేమ్ నెంబర్ n. సో కాన్వర్స్ need not be, కాన్వర్స్ ట్రూ కాదు. మీకు నెక్స్ట్ కౌంటర్ ఎగ్జాంపుల్ ఇస్తాం. నెక్స్ట్ ఫిఫ్త్ ప్రాపర్టీ, if A congruent to B modulo n, if A congruent to B modulo n modulo n, then A dot C, A into C congruent to B into C modulo n. అంటే ఏదైనా ఒక నెంబర్ ని బోత్ లెఫ్ట్ సైడ్ రైట్ సైడ్ మల్టిప్లై చేస్తే కాంగ్రెన్స్ రిలేషన్ ఏం మారదు. ఇఫ్ A congruent to B modulo n, then A into C congruent to B into C modulo n, but converse need not be true. If A dot C is equal congruent to B dot C modulo n, అప్పుడు A is not congruent to B modulo n. Converse need not be true. Converse true కాదు. Converse need not be true. మీకు ఎగ్జాంపుల్ ఇస్తాను, not be true. I'm giving counter example. Then sixth property, if A congruent to B, if A is congruent to B modulo n, A is congruent to B modulo n, then I can power squaring A square, B square, A cube, B cube, A power n, A power k is equal to B power k. So A to the power of k is also congruent to B to the power of k modulo n. Aim change కాదు ఇక్కడ. A power k, B power k, where k is equal to natural numbers 1, 2, 3 like this. So seventh one, if A congruent to B modulo n, if A congruent to B modulo n and D greater than 0, my number is D greater than 0, D divides n, D అనేది D is divides n అంటే n is divided by this number D, D is positive, n is divided by this number D, then A is congruent to B modulo D. అంటే ఇక్కడ మాడులో చేంజ్ చేయడానికి వాడుకున్నామండి. A congruent to B modulo D. D ఉంది ఇక్కడ n ఉంటే ఇక్కడ D. మాడులో టర్మ్ చేంజ్ చేయడానికి ఈ ప్రాపర్టీ వాడుకోవచ్చు. అంటే D divides n, we can write A is congruent to B modulo D. This is the eighth property. It is the most important property. ఇందులో ఈ ప్రాపర్టీ, this is and A power k, B power k and A into B is equal to AC. These properties are important. Next one is the most important property, AX. If AX congruent to BX, AX congruent to AY తీసుకున్నాం. AX congruent to AY, AX congruent to AY modulo n. ఇది ఇంతకుముందు చాలా సార్లు అడిగాడండి క్వశ్చన్ సిఎస్ఆర్ లో, నెట్ లో, సెట్ లో కూడా. AX congruent to AY modulo n if and only if. ఇప్పుడు జనరల్ గా మనం ఏ క్యాన్సిల్ చేద్దామంటారు, కానీ ఇక్కడ ఎప్పుడు పాసిబుల్ అవుతుందంటే X congruent to Y modulo n divided by GCD of A comma n. కొన్ని టెక్స్ట్ బుక్లలో X congruent to Y modulo n divided by D, where D is the GCD of A comma n. Modulo n by GCD of A comma n D తో డినోట్ చేస్తారు. X congruent to Y modulo n by D రాస్తారు. అంటే ఇక్కడ A ను లెఫ్ట్ చేయాలి, లీవ్ చేయాలి అంటే ఖచ్చితంగా GCD ఆఫ్ ఇక్కడ మారిపోతుంది. మాడ్యులో టర్మ్ మాడ్యులో చేంజ్ అయ్యేది ఎక్కడెక్కడ చేంజ్ అవుతుందంటే హియర్ మాడ్యులో టర్మ్ చేంజ్ అయింది, ఇక్కడ కూడా మాడ్యులో టర్మ్ చేంజ్ అయింది. సో ఇక్కడ రెండిట్లో మాడ్యులో టర్మ్ చేంజ్ అయిపోయింది. నెక్స్ట్ ప్రాపర్టీ, ninth one. Okay, this is if A congruent to A is always congruent to B modulo 1. A is always congruent to B modulo 1 for all A comma B. For all A comma B. ఇది కూడా which of the following is true అడిగాడు. A is always congruent to B modulo n. నువ్వు ఏ నెంబర్ తీసుకోండి, ఏ నెంబర్ తీసుకున్నా కూడా, సో 1 divides A minus B, every number is divisible by 1. ఏ నెంబర్ తీసుకోండి, every number 2, 3, 4 including 0 is also divisible by 1, so that A is congruent to B modulo n for all A comma B. 10th one, A congruent to B modulo n, A congruent to B modulo n if and only if A modulo n is exactly equal to B modulo n. B modulo n. A modulo n is equal to B modulo n, right? A is congruent to B modulo n is nothing but A modulo n, B modulo n అవుతుంది. Now another one, ఇంతకుముందు చెప్పాను, if n greater than 0 and A is congruent to B modulo n, modulo n, A is congruent to B modulo n, then GCD of A comma n, A kunnu n, GCD of A comma n is same as GCD of n comma B. Just now we discussed this problem. Fine. These are the 11. One more is, this is small note also. This is also written as, yeah, minus A is congruent to any number minus A is congruent to n minus A modulo n. Yeah, these are all of the congruence relation properties. By using these properties, one question compulsory any examination find out. Right? See, now I'm proving few of them. కొన్ని prove చేయడానికి ప్రయత్నం చేస్తాను. Proof for first one. What is the first one proof? A congruent to ఏమన్నాడు? Reflexive property. A is congruent to, we are proving that A congruent to A modulo n. Yes, but one thing is very clear. N divides A minus B. N divides A minus B. We can write A congruent to A modulo n. Yeah. See one thing clearly. What should we write means here? N is divides 0. 0 is divided by n. Every number 0 is divisible by n. N divides 0. Clearly n divides 0. So I can write this as n divides A minus A. N divides 0 astunnanu. 0 means A minus A. So that n divides A minus A means, what is our rule? If n divides A minus B, n divides A minus B, then A is congruent to B modulo n. This is the condition. Right? So n divides A minus A, so that we can write A is congruent to A modulo n. So this means what? Reflexive properties satisfied. Next one is the symmetric property. Symmetric property improve cheyachu ikkada. If A congruent to B modulo n, A congruent to B modulo n ante edi, then n divides A minus B. Then n divides A minus B. So means n divides A minus B means there exists an integer k such that A minus B is equal to nk. A minus B is equal to, suppose k1 anukunnam, where k1 belongs to z. A minus B is equal to nk1, where k1 belongs to z. And also another condition is B congruent to, yes, A congruent to B. Very simple. I'm writing this is equal to, no need to write this one, simply I'm leaving this one. Yeah, n divides A minus B is same as n divides A minus B is same as n divides minus common istunnanu ikkada chudandi, just n divides minus of I'm writing this as A minus B. N divides A minus, you see any number n divides n అయినప్పుడు automatically n divides minus n కూడా అవుతుంది. So n divides అంటే A minus B is divided by n, automatically minus of A minus B is also divided by n. So n అనేది A minus B అంతా ఎంతో డివైడ్ అవుతున్నప్పుడు minus of A minus B కూడా ఎంతో డివైడ్ అవుతుంది. అంటే దీన్ని n divides minus of A minus B nothing but B minus A. So n divides B minus A means, what should we write? B is congruent to A modulo n. B is congruent to A modulo n. ఇక్కడ మీకు చూడండి n divides A minus B అయింది అనుకోండి, A minus B ని n డివైడ్ చేస్తున్నప్పుడు ఆటోమేటికల్ గా A minus B ని minus n కూడా డివైడ్ చేస్తుంది. Okay, right? Therefore B is congruent to A, then A congruent to B, then B congruent to A modulo n. This property is known as the symmetric property. If A congruent to B modulo n, then B is also congruent to A modulo n. It is the second property. Third, this is a transitive property. Transitive property ఎలా prove చేయొచ్చు? If A congruent to B modulo n, A congruent to B modulo n తీసుకున్నాను. అప్పుడు ఏం తీసుకుందాం మనము? According to our definition, n divides A minus B. N divides A minus B. Okay, this means there exists an integer k1. A minus B is equal to nk1. K1 belongs to Z. This is my first equation. Similarly, ఇంకోటి ఏముంది? B congruent